Midnight to 010, hook. What if I told you that when you ask an AI to add 36 plus 59, it doesn't just know the answer? It first guesses 40-ish plus 60-ish equals 100-ish, then separately calculates that the last digit must be 5. And only then combines them to get 95. That's not a bug. That's how AI actually thinks. And for the first time ever, we can watch it happen. 010 to 030, context. Anthropic just dropped 2 papers that change everything we thought we knew about large language models. They built what they call a microscope for AI, a technique called circuit tracing that lets researchers peer inside Claude 3.5 Haiku and watch its decision-making process step by step. No more guessing. No more analogies. We can literally see the computational graph of a frontier model as it reasons. And what they found? LLMs are even stranger than we imagined. 030 to 230, main content. Here's how it works. Traditional interpretability looked at individual neurons, but neurons are messy, polysemantic, hard to interpret. Anthropic's breakthrough uses something called cross-layer transcoders, or CLTs. These replace the model's dense MLP layers with sparse, interpretable features. Think of them like concepts the model uses. Each feature fires for a specific idea: smallness, opposites, baseball, the color red. Then they chain these features into attribution graphs, computational pathways showing exactly how input tokens flow through features to produce output tokens. It's a wiring diagram of the model's thought process. And the discoveries are wild. Take simple addition. Ask Claude to add 36 and 59. The attribution graph shows, first, features for approximate magnitude activate 40-ish and 60-ish. The model computes 100. Separately, features for last digit arithmetic fire 6 plus 9 equals 15, so the answer ends in 5. Only at the final step do these two streams merge, 95. The model didn't learn this algorithm from training data. It invented a multi-step heuristic estimate, then refined that no human taught it. Or take the don't speculate circuit. Anthropic found a feature that literally suppresses hallucination. When Claude knows the answer, this feature stays quiet. But when it's unsure, the feature activates and forces a refusal: I don't know. Except, sometimes a stronger helpfulness feature overrides it, and the model hallucinates anyway. We can now see the tug-of-war between safety and usefulness happening in real time. They also caught the model planning ahead. In a poem about baseball, features for rhyming structure activate before the model writes the first line. It's not predicting next token, it's structuring the whole response in advance. And multilingual? The same smallness feature fires whether the prompt is in English, French, or Chinese. The model has genuine language agnostic concepts. 2:30 to 3 o'clock, implications. Why does this matter to you? 3 reasons. First, debugging. When your AI agent goes off the rails, we'll soon be able to trace exactly which circuit fired and why, no more black box guessing. Second, safety. If we can see the deception circuit or the power-seeking circuit activate, we can shut it down before it scales. Third, trust. Dario Amodei has warned that interpretability is lagging dangerously behind capabilities. This is the first real evidence we might catch up. 3 to 315, CTA. Anthropic just open sourced these tools. You can run circuit tracing on Gemma and Llama models right now via Neuronpedia. Link in the description. If you want to see the actual attribution graphs and the weird math circuits, check out the papers, they're fascinating. And if this blew your mind, subscribe. We're covering the interpretability revolution as it happens. What's the strangest thing you've seen an AI do? Drop it in the comments.